I'm going to give a short attempt to explain exponential growth and exponential decay. Exponents of the functions are the form a b to the x, and if b is greater than 0, or excuse me, greater than 1, then this is growth. And if b is between 0 and 1, or that is less than 1, so it's between 0 and 1, it's going to be exponential decay. So this first one, letter A, is 1/5 is my b value, and so this would be decay. The second one, 4, is positive, so it's growth, and 1.2 is more than 1, so it is growth as well. This story, we have farmland. You can pause it to read the story if you want. We have the function is equal to ab to the x. This is going to be exponential decay, and we need to know what b is in order to solve this. We know that it's dropped to 80,000 and it started at 102,000. So our a value is 102,000, and it's some value of b. And between the year 1983 and 1998, there were 15 years. So we'll raise that to the 15th power. And we need to figure out what b is. So we'll do the inverse operation. We'll divide both sides by 102,000 to get, I think it's 0.78, yeah, about 0.78. And that's equal to b to the 15th power. So we need to know what b is. So if we take the 15th root of both sides of this equation, then we get the value for b. And our b value would be, it's about 0.98. And now we can substitute that value of b into our original equation. So we have the function of x is equal to 102,000. That's our a value, and it doesn't change. It's the starting value, 102,000 times 0.98 to the x. And that's going to be our function, which is an exponential decay. Okay, for the next part of this, first of all, let's write the function again. The function of x is 102,000 times 0.98 to the x. Well, I think I have a mistake in my writing here, so just get ready, it's coming. I've got a mistake here. We want to know between 2010 and 1983 is 27 years. And how did I get that? Well, I subtracted 1983 from 2010. So it's 27 years. This is going to be, so I'll rewrite my function and try to solve for f of x, solve for what it would be in 2010, or what it was in 2010. So we have 102,000 times 0.98, and it should be to the 27th, and I think I wrote to the 15th. Yeah, I wrote it to the 15th. Should be to the 27th. But the answer here is correct. It's 59,115. Okay. Now we're adding exponents because we have a product of powers as the common base. So you add the exponents. You cannot simplify this, so that's my answer. The square root of 3 plus the square root of 5. Here we're going to multiply the radicals, and when you multiply the radicals, I get a radical. So I get 7 times the square root of 6, and that's going to be my answer. To solve these, the bases need to be the same. So I can rewrite 81 as 3 to the 4th power. And now if the bases are the same, that means that the exponents have to be equal if our two equations are equal. So I'll just solve for n. We get n is equal to 3/2. And we can substitute it back into the original equation just to verify that it's correct. We can check our work. So we have 3 to the 2 times 3/2 plus 1, which is 3 to the 4th, which is 81, so that checks. The second equation here, I'm going to rewrite this as 2 squared to the 2x is equal to 2 cubed to the x minus 1. And when you raise a power to a power, you multiply the exponent, so that's going to be 4x is equal to 3x minus 3, and x is equal to negative 3. We can substitute that in as well to see if it works. You get 4 to the negative 6th is equal to 8 to the negative 4. And yeah, that's going to work. That checks. Now for this last one, 256 happens to be 4 to the 4th. So 4 to the 3p minus 1 is equal to, or is greater than, 4 to the minus 4th, because it's going to be 1 over 4 to the 4th. So 3p minus 1 is greater than negative 4, or 3p is greater than negative 3, which means p is greater than negative 1. And that's my solution. Here we have x squared. This is going to be a quadratic. The next one, we got an exponential growth. It's going to be because the b value in our equation is greater than 1. And this next one is y equals mx plus b. That's a line that's linear. And finally, we have the less than 1, between 0 and 1. So this would be exponential decay. And what do these look like when you graph them? Here's some graphs. This looks like growth. It's got a y-intercept of 2. Now notice that's the a value, is the y-intercept. So that's 2. That goes with number 4. Letter B, that's decay, and it's the only one that's got a fraction here. So this is going to be decay. And the third one has a y-intercept of 1. And if we look at our original equation, it's got 1 as well. So good luck and success.